We are now starting section 1.2, and this focuses on some really important vocabulary terms. And you'll notice the title says points, lines, and planes. So to start, you'll notice the very first term is the word definition. We've obviously know what definition is, but it says definition uses no words to describe a new word. So we're going to use words that we already know to kind of give an idea of what the new word is about.
Who knew we were going to be giving a definition of a definition in this class?
I know, kind of crazy. We also have what we call an undefined term, which sounds kind of weird because you're defining an undefined term. The whole thing about an undefined term is you'll notice it says it's a word that is not formally defined. So a lot of times how I think of it is it's just like we come to a general idea, agreement. This is what this word is about. A lot of these types of terms in geometry are like point, line, and plane are your key examples for undefined terms.
All right. So let's talk about them.
All right, so this slide here has your nice little table set up. You'll notice the far left is the term, then the definition, which we already have listed. We're going to draw a picture and do a little notation of it, which is a big thing in geometry. It allows us not to have to write a bunch of words, which is nice.
Yeah, mathematicians like to be as short and concise as possible.
It's not being lazy. It's just being smart.
That's right.
So to start off with, point. You guys have used points before, but notice the definition, it has no dimension. It's a small dot. So you've used points a lot of times in algebra last year to draw a location on a coordinate plane. So Mrs. Hope Graby drew a lovely point, and notice right next to it she did a capital letter. She chose the letter A. That is how you name points. So when you name a point, you can call that point A, or sometimes you just say A. And notice it's capital A. That's important. It's not a lowercase. Points are always named with capital letters.
Absolutely. Now a line is something that extends in one dimension. So you're not going to be talking about multiple, you don't need to worry about 3 dimensions here, or 2 dimensions even. It's just one dimension. And it contains at least 2 points. Now there are an infinite number of points on a line, but we're going to just be looking at to name them using 2 points. You need at least 2 points that you can see. Your lines should be straight. We're not going to have weird curves going on. So a straight line, you'll notice that we'll put arrowheads at the end of our lines. And I'm going to go ahead and call this point A and point B that it goes through. So how would I refer to that?
You could call it line, and I think you can name it line AB because those are the points on there. Another way, again, we mathematicians we don't like to use words, so you do AB with a line above it.
And this is how you're going to see us refer to this in class.
And to stress about Mrs. Hope Graby's picture, the reason why she drew the arrows, which you guys have dealt with before, is it to show that it goes on forever. So part of the definition, you could kind of even say that lines never end. They keep going and going and going.
Absolutely. Now sometimes in your book you're going to notice they'll put like a cursive lowercase letter. I can't talk today. That will be right next to that line. And that's another where I could refer to this as line L, the way that I've written it as well.
So even a shorter way.
Well, I don't know. I still think the notation of AB is probably a little shorter. But yeah, another way we could write it.
Could we also write it as line BA?
Good question. Absolutely we can. Because we know that AB and BA, if it's a line, there's no starting point, no ending point. It just has to contain those. So we could also call this line BA.
And to stress what Mrs. Hope Graby said a little bit ago about the fact that there could be lots of points. So if you have multiple points on that line, as long as you name a line with any 2 points that are on that line or by the lowercase cursive letter, that would work. The next undefined term is a plane. Now, a plane is kind of hard to kind of think about. It's not like an airplane in geometry. A lot of times when I think about this is geometry world. So in a plane, notice it extends in 2 dimensions. So we start with point, no dimension, line 1 dimension, now with 2 dimensions. It also contains points, but notice a plane contains at least 3. And it says non-collinear points. We'll come back to that word here shortly. So it has to have at least 3 points. And a lot of times when you draw it, so she's going to start just drawing 3 points, random. And notice they're not all on the same line. That's what non-collinear means. And
so collinear means on the same line.
Okay.
Non-collinear, not all on the same
line.
line.
Now, to show that it is a plane, she's going to draw kind of like a quadrilateral surrounding it. Now, a plane doesn't have to have 4 sides. And actually, because it extends in 2 dimensions, it goes on in all of those kind of spaces.
So it'd be almost as if I could draw little arrows in every direction going around there to show that it goes on forever.
A lot of times when I think of a plane, I think about if you look right in front of you on your desk, the surface of your desk is a plane. Anything that's 2-dimensional is a plane. To name a plane, like a line, you name it by its points. So you need at least 3 points. So I'm going to call this plane, let's say, ABC. And you could name it a CB, as long as you name it with 3 points.
Now, sometimes, just like the line, you'll see another lowercase.
Uppercase.
Or no, it is uppercase. That's true. In a plane it is, isn't it? Where we're going to have, like, maybe I could call this plane M. And you'll just see it kind of, usually it's in the corners where just somewhere but it's not a point that's on that plane. It's just showing us that this is plane M.
And it's usually cursive. I don't know how good of cursive Mrs. Hokgravy did there.
Sorry. I know, I don't really.
I'm not good at cursive either. But you'll be able to tell in the book or a worksheet, it's pretty obvious what's the cursive versus the normal print.
Absolutely. Now, line segment. It's part of a line. So we know that a line, we've already talked about it, it extends just in 1 dimension, contains at least 2 points. This is part of a line, but it has endpoints. It has 2 endpoints. So it does not, we're not going to draw the arrows to show it goes on forever. We're going to show that it has endpoints. And it would consist of those 2 endpoints and all of the points that were between them. So instead of extending my line with arrows, I'm going to leave it as just the segment with 2 variables at the ends to show my endpoints as A and B. It could have other points on there as well, but we just need 2 points to be able to determine that that's a line segment. And we could again write segment AB, or the shortcut way to write that would be an AB with just a segment above it. Instead of a line with the arrows, it's just the segment, no arrows.
So just kind of stress what Ms. Hokgravy is saying. Again, a line segment is part of a line. So it has the characteristics of a line. It has at least 2 points. It's 1-dimensional. Lines actually contain segments. So if you go back up and look at the line she drew a couple rows above, that line actually contains a segment on it. That is the segment that's part of that line. So there's a lot of things, characteristics that are similar. Now you could also name line segment that she drew. Instead of segment AB, you could call it segment BA.
Absolutely.
And the reason why, again, is because it has the same 2 endpoints and the points between.
Okay.
Ray, the last term that we have on here, is, again, it's also part of a line. So it's going to have characteristics of a line and a line segment. But the big difference is that it actually contains an initial point, so kind of your starting point, and it extends in 1 direction. So instead of extending in both directions like a line, instead of like a line segment, it has 2 endpoints. It's just going to have basically an initial point and then a point. It has got to go through another point. So you're going to see at least 2 points still on there to show that what direction it goes. And that's what a ray looks like. Naming it ray, maybe AB. And we can use our shortcut notation, AB with a ray above it.
Now, on this one, could I name this Ray BA, Mrs. Palermo?
Well, if you name it Ray BA, that means the initial point would be B, and then it would extend past point A. What do you think?
I don't think so, because it doesn't look like that's happening in this one, right?
So rays are restricted to how you name it. You have to name it with the initial point first, and then extending on.
Okay.
Now, the next 3 terms that we have here, we've already mentioned collinear. All right, it says collinear points are points that lie on the same line. Now, a line contains at least 2 points, right? So if we were talking about collinear points, points that lie on the same line, 2 points always are on the same line. So how many points do you think we need?
We just need 2 then, right?
Well, if we need 2, that means all points are collinear.
Oh, so we need 3.
So we need at least 3 points to be considering
collinear. Because otherwise, of course, there's going to be a line between them.
Exactly.
Oh, okay. Well, then what about coplanar? Because we know that we said it before when we were trying to define a plane, we needed 3 points to make a plane. So can I just have 3 points and call them coplanar?
No, because then that would make all points coplanar.
So that means that we need at least 4 points to be talking about something being coplanar or on the same plane, to be something that's unique, because any 3 points, there's going to be a plane that exists between them.
And again, that word, kind of that prefix co, kind of talking about how it's sharing. It's on that, they share that line or plane. In collinear, you can also have collinear segments, collinear rays, things that share in that. You could have coplanar rays, meaning the rays are in the same plane as well.
Yeah.
They just threw in just points as an example.
Absolutely. Opposite rays, that's when we've got rays that share the same initial point and they're collinear.
Okay, so how would this work? You have to have rays that share the same initial point. So if I draw a ray, and I gotta have at least 2 points, so I draw a ray here, I'm gonna change it up. I'm going to do capital M and capital N. So this is ray MN.
So if I want to make an opposite ray from that, it has to share the same initial point. So it's still going to be M something. We just need to figure out what direction we want it to go.
So I gotta make it collinear too. So if I draw it like just straight up, they're not on the same line. So what if I go this way, directly opposite of it? I'm going to name this maybe point Q. Just change it up.
So yeah, so there we've got an example. They share the same initial point. We'd be talking about ray MN.
So this is the initial point. This is that same initial point. So you have ray MN, and I'm going to name it with my shortcut notation.
Absolutely. And then ray MQ. Those are going to be considered opposite rays because they have that same initial point and they are collinear. They're on the same line.
Perfect. And notice in the end, the opposite rays make a straight line.
All right, to intersect. When we talk about things intersecting, I say things because we could talk about lines or rays or segments or planes intersecting. When they're intersecting, they're going to have 1 or more points in common. So if I have lines that are intersecting, they're going to be 2 lines that are going to have a point in common. I drew segments, but we could continue those with lines. I could talk about segments that would intersect at a point. I could talk about 2 planes intersecting, but notice here where these 2 planes are intersecting, they're intersecting at a whole line. There's a lot of things that they have in common.
And a lot of points, so it's not just 1 point. So when it says intersect, that's why she's saying 1 or more points. Planes that intersect share multiple points.
Right, because every point that's on that line would be a point where they would intersect.
And so where they intersect is called the intersection. It's the set of points that the figures have in common. So 2 lines intersect, they only have 1 point. 2 planes intersect, have multiple points, and it's all along that segment.